people. So let's do this. So I was going to scroll this up. And then we'll go over, I'll show you at least the answers for the problem. And I gave you a practice quiz. So we'll talk about that too. All right, so first, obviously, we need to find the second derivative. Where the second derivative is positive, it is concave up. Where the second derivative is negative, it's concave down. So we just got to figure out where the second derivative is positive or negative. So we just know we got to do that. So we can write this as this is a cube root, so as some of you did. So y is x minus 2 to the 1/3. So the first derivative, y prime, is 1/3 x minus 2, take away 1 to the negative 2/3. And the second derivative, negative 2/3 times 1/3 is negative 2/9, right? Negative 2 times 1 is negative 2. 3 times 3 is 9, yep. X minus 2, take away another 1 from there, so that's a negative 5/3. Okay, we're done. Super easy. I mean, that's like a 10-second thing. Now, now first off, negative exponents are hard to understand. So let's rewrite this now in a way that makes sense. Negative 5/3 is in the bottom. On the top, we have negative 2. On the bottom, we have a 9 times, and I'm just going to put x minus 2 to the 5/3. Minus, to the 5/3. Okay, so for critical numbers, we want to know when, we want to look at this one, because that's the interesting points. Where is that 0 or undefined? Okay, so let's rewrite this one too. So that's 1/3 x minus 2 to the 2/3. Is there any place where this is 0? And it's only 0 when x goes to infinity or negative infinity. So we know that for really big x's, the slope goes to 0. Eventually, this thing is going to go approach 0 if we go far enough that way, and approach 0 if we go far enough that way. Now, I don't know if it's going to approach 0 from the bottom or the top yet. I just know it's going to go to 0. But there is no other place as 0. There's no peaks. There's no troughs. The only place this is 0 is if we go to infinity. It's kind of weird. Okay, how about where, but remember, critical numbers are where it's undefined or it's 0. Is there a place where this is undefined? And at x equals 2, it's undefined because we're dividing by 0, right? So the only critical number is x equals. However, what do we have to check to make sure that that's a critical number? That it's in the domain of the original function. But it is. If I can put in 2 here and I just get y is 0 to the 1/3, which is a totally reasonable thing. So 2 is in the domain of the function. And because it makes the derivative undefined, it is a critical number. So this is like one of those opposite cases. Normally, we've been getting critical numbers where the slope is 0. But now we're not getting the only critical number is the slope is undefined. So it's kind of backwards from like normal ones, which is why I want to do one like this, because it's kind of interesting. Remember, and that's only because it's not in the domain of the function. I mean, because it is in the domain of the function. 2 is a perfectly good number for the function, but it's not allowed in the derivative. Therefore, it's a critical number. Therefore, something interesting. The slope is infinite at x equals 2, which means it's straight up and down. Okay? So now we just want to know where is this. So all we got to do is look at either side of 2 and say what's the second derivative on either side of 2. So here's our second derivative. So let's plug in a big number. Let's say 5. No, let's say 3, because that's really good. So at x equals 3, we have 1. 1 to anything is 1, so it's negative 2/9. So at x equals 3, the second derivative is less than 0, because it's negative 2/9, because this is just 1. How about the other side? Let's say x equal, what's a good number? 1? Why not? Let's say x equals 1. When x equals 1, it's negative 2 over 9 times 1 minus 2, negative 1 to the 5/3. Okay. Negative 1 to the 5th is negative 1. Odd, right? So negative 1 to the 5th is negative 1. The cube root of negative 1 is negative 1. Negative 1 times negative 1 times negative 1 is equal to negative 1. So this is negative 1. So it's negative 2 over 9 times negative 1, which is 2/9. So the second derivative is greater than 0 over here. So from minus infinity to 2, greater than 0 means it's concave up. And if you don't want to write concave up, just put an arrow. That's totally fine. Do that on the final. Concave up is a lot to write. Goes up. And then from 2 to infinity, and always put parentheses because we don't include 2. We can't include infinity. Don't put brackets, put parentheses. And then it's concave down. We're done. Now, what does this look like? It's kind of interesting. So if we were to graph this, I believe it looks like this. It's straight up and down at 2. And then it goes like this, goes to 0, and goes to 0. So the slope slowly goes to 0, and here's x equals 2, right there. So x equals 2. And it's undefined. It's straight up and down there. It's a vertical slope right there. And then it goes to 0 like that. So that's what this graph actually looks like, which makes sense. It's never a slope of 0 except at negative infinity and positive infinity. It's got an infinite slope at x equals 2. Anyway, kind of cool. Now to figure out that, we would have to do a little bit more, but I didn't want to take the whole period on this thing, right? Just kind of get the idea here. So, okay, so over here, notice it's concave up. It's curving like this, so it's concave up. And notice here it's concave down. It's kind of curving down. Are there any inflection points? Yes, so at x equals 2 is an inflection point. What is the second derivative at x equals 2? 0. Is it? No. The second derivative is undefined at x equals 2. We're dividing by 0. So this is a case, again, where the inflection point is not a place where the second derivative is 0. It's a place where concave up switches over to concave down. So inflection points, if the second derivative is 0, it's an inflection point. But that's not that's not a necessary condition. You can have an inflection point without the second derivative be 0. I think it has to be infinite, though, undefined. So like asymptotes can be inflection points. Or, in this case, undefined second derivative can be an inflection point. So you got to be careful with inflection points. They're not defined as with a second derivative of 0, though that is an inflection point. They can also be an undefined or vertical things. So, kind of crazy. Anyway, this is a good example that kind of breaks all the normal rules, right? So you got to think carefully about the definitions because this one's a little bit different. The one from the homework was a little bit weird too. Number 4. So I can put up the answers there and see how everybody did. But first, okay, I did this last period, so I have it already. You guys all know that a centimeter cubed of water weighs a gram, right? So, and you might not know, but you can look it up. That turns out that there's 454 grams in a pound. If you look at your can of food, whatever, it says 1 pound, 454 grams. It's fine. So 454 centimeter cubed is a pound of water. Now I know that an inch is 2.54 centimeters, which is 30.40 centimeters inside. 30 times 30 times 30 is this many centimeters cubed in a cubic foot. Divide that by 454 cubic centimeters. You get, that's how many grams are in a cubic foot. So a cubic foot of water is 28,217 grams, which is 62 pounds. So if you have a box of water, a foot in the side, it's about 62 pounds, which is worth remembering forever maybe, that a cubic foot of water is about 62 pounds. Now a gallon of water is about 8 pounds. So a cubic foot of water is like almost 8 gallons. So if you have a box, foot in the side, like you have a water container. So if you're like, I don't know, I have a 5-gallon container of gasoline at home, right? Probably a lot of you do. That's not quite a cubic foot, right? A cubic foot is almost 8 gallons. That's like 5 gallons. So, you know, and it's kind of looks like a foot, but it's not quite there. Yes?
It's kind of dumb, but how, like, when you go underwater like a foot, does that mean there's like 62 pounds of pressure? Or like, what is that?
Well, that means that on every square foot, there is 62 pounds of pressure, which is why I'm talking about this. So on your roof right now is probably a bunch of snow. And I know in Leavenworth, it used to be 75 pounds per square foot is how they built your roof. You had to, back like when I built a house in early 2000, we had to build it to 75 pounds square foot. They call it the snow load, right? Every square foot of your roof had to be able to hold 75 pounds. Okay, now 1 foot of water is 62 pounds. So 75 pounds is about, okay, you can do the math, but a little over a foot of water, right? Let's say 14 inches or something. So let's say 14 inches. So a typical roof in Leavenworth was built to have 14 inches of water. So when you get enough snow up there, so if you go out and how much water is in like this much snow? Because on my roof right now, it's maybe this deep, more than 14 inches, but you know, you can press it down. If you melted it, it's not going to be 14 inches of water, right? It melts down to, I don't know what. You got to go do that, which is kind of a pain. It's not hard to do. But yes, so my roof can hold for it. If not, then I don't know, my roof collapses or something. That'd be kind of a bummer, right? And I know like my neighbor yesterday was out shoveling off his roof because he's got an older house that maybe wasn't built to 75 pounds. So older than, I don't know when the rule came in, but you used to just build a roof and call it good. So a lot of older houses, sometimes the roofs collapse because they didn't have those codes back then where you had to have your trusses, whatever, specified to 75 pounds. Now they raise it to 85 pounds because there are some problems with 75 pounds. Some people's roofs were still collapsing. When I built my house out on Icicle Road, it was 75, and I said, yeah, but I want to have a stronger roof than that because I don't trust that. So I made it 85, and then about 5 years after, they made that the rule everywhere. So I kind of saw it coming or something, I guess. Because I didn't want to have to worry about shoveling my roof. Anyway, I'm starting to worry about shoveling my roof because there's going to be a big snowstorm tonight, if you haven't heard. I really hope it's a late start tomorrow because it's not supposed to stop by the time school starts. It's supposed to keep snowing really hard to like noon or something. Well, it said, no, you don't want to cancel school because we got to make it up. But they don't have to make up late starts. So I'm hoping at least it's a late start. Anyway, I'm starting to worry about my roof, is what I'm trying to say. Tilly had her hand up first. What?
I was talking to my piano teacher, and she went to the high school in town, like, not, so like, before the old high school, there was like a different one, and they built it so poorly that it had like a flat roof, and they had to like, get students and shovel it off.
Yeah.
And she was talking about that, how there used to be like so much more snow, and they constructed it so poorly, they like took time out of class.
Yeah. So depends first how strong it is, and then of course flat roofs don't shed snow, and they might even gather water. If the water melts, it stays there, right? At least my roof is not metal, so metal roof, if it slides off, you're solid, right? Except for sometimes you can lose the dog and it slides off or something, or people. But I thought I lost my dog once. We heard, oh, where's Bo? Big. Oh, she wasn't wearing an avalanche beacon. Darn it. She put an avalanche beacon on the dog. But she was okay. It ended well. And after we panicked for like 5 minutes, and oh wait, there she is. We're like, what are we doing? What are we doing? Oh. I don't have a metal roof anymore. That was a different house. So I got to. But yeah, at least if it's pitched, if it melts a little bit, it runs off like the icicles are like this is the most icicles I've ever seen in Leavenworth. It's crazy all the icicles have, which means your snow is melting a little bit at least. Yeah. Yeah, it's crazy, huh?
It's kind of interesting. Anyways, like earlier this year, like my neighbor was walking out and got hit in the head by a icicle and like had to go to the hospital because like.
Oh my God, I wonder about that. There's some big ones. I've seen houses where they've hit the ground now, right? They're like in a cave where the stalactite and the stalagmites meet. There's like icicles all the way to the ground from people's roofs. Yeah. Yeah, they clinkle. Now, if you see a house with a lot of icicles, that means basically they don't have a good insulated roof because the heat from the house is melting the snow and it drips off and then refreezes, right? So houses with no icicles have well-insulated roofs. So you can kind of tell how good the roof is insulated by how many icicles you have. My house, unfortunately, has some icicles. I didn't build the house I'm in now. The one I built, of course, has like 0 icicles. Anyway, so the question is, how deep of snow do you got to get to where you get to 75 pounds where you're like, uh-oh, I better go shovel my roof or anything, max the snow. Now, hopefully, they put a little bit of fudge factor in there, so maybe it can hold 80 or 85. But when do you got to start worrying? And there's no number because snow is different. And tomorrow, it's supposed to get a lot of snow, and then it's supposed to warm up and maybe rain on top of it. And that's when it gets bad. Because then the snow gets really heavy. Because it captures the rain just soaks in and maybe turns into ice. And suddenly, yeah, this much snow now weighs a lot more, right? So that's when it's dangerous, when it rains on top of the snow and you're wondering, oh, it's only 3 feet, but yeah. Okay, so our magic number is about 14 inches of water. So if we look at Stevens Pass, because we can, this is the snow water equivalent. And I don't know how they do this. Someone's got to go out there and melt the snow every day. Take a foot cubed, melt it, and see how deep it is. But so we are, okay, or you can weigh it, but you still got to take a slice of snow, and they probably have a way to take a slice of snow, and they can weigh it, and they know how big a slice is. So yeah, you don't have to maybe melt it and measure it, but you could. But that would be easy to do too. Just let it melt and see how deep it is. So I take a slicer. That's probably what they do. They have some slice all the way down to the ground. Let it melt, and oh, it's this much water. So something like that. But right now, we are exactly average at Stevens Pass. The green line is average. We started off, remember, with some snow. We're the black line. And then it all melted when we got a bunch of rain in early December, and all our snow went away. And then it got cold and started snowing like crazy. So we had some snow, melted, and then, boom, we're the black line. My guess is, if we look at this on Friday, my guess is we're going to be somewhere way above. The green line is average since they started doing this. I think it's like for 40 years they've been measuring snow up there. My guess is we're going to be up here because it's supposed to get dumped on in Stevens, plus down here it's going to get dumped on. Oh, by the way, this year, see this outline? That's the biggest snow year ever at Stevens that they've measured. I think it was 96. And this line is the worst snow year they've ever measured.
Oh,
That is sad.
There's like no snow. And we can look at those numbers. I forget.
When was the worst one?
Yeah, I think they have that underneath here.
It was like 2000.
Oh yeah, this is the 30-year average, right? Because this is our 30-year average is the green line. When are the worst ones here?
2015 was a pretty awful year at Stevens. Like we didn't actually get filled in.
Looks like 1980 was bad. This is the what? This is.
Yeah, it's out there.
Okay, yeah, it was 96 is the biggest, the worst historical most water. 97, okay, sorry, 97. Well, but the question there is the winter 96 into 97. I think it was the winter 96, 97. So they had 72 inches of water. Okay, now 12 inches weighs 62 pounds. That's 6 times that. That's 360 pounds of water per square foot on your roof. They have, hopefully they have metal roofs and it slides off. Now the worst was down here. That was in 1980, I guess. Only 3.8 inches of snow is the most they ever had at Stevens. I mean, that's like this much snow. It's the most they had.
That's what Jimmy Carter being president will do to this.
That's terrible. Yeah. All right, so that's the record. Now this is like only since 1980, but that's 40 years. Last year was pretty good. Last year was 51.8. All right, anyway, okay, now this is the interesting graph. This is how deep the snow is versus the snow water equivalent. So right now, Stevens Pass has about 6 feet of snow where they measure this, right? Because that's 72 inches. 72 inches is 6 feet. 6 times 12 is 72. That's how tall I am. I'm, well, maybe 6'1" or something. But so it's basically as tall as I am, 6 feet. That's how deep the snow is. But if we melted the snow, the amount of water in it would be the snow water wait. Snow depth is green. That's here. Snow water equivalent is there. That's this number we looked at before. So it's only about 18 inches. So there's 18 inches of water on Stevens Pass, which if it was in Leavenworth would be bad because my roof can only hold 14 inches. So the amount of snow on Stevens Pass might collapse in my roof, but we don't have as much snow at Stevens Pass. But what fraction of it 18, 3 times 18 is 54. 4 times 18 is 72. So right now, at Stevens at least, the snow is 4 times deeper than the water. If you melted it, it'd be 1/4 as high. So assuming that's the case in Leavenworth, then I could take 4 times 14, I could take 56 inches of snow, which is 4.5 feet, roughly.
Yeah.
So my roof should, I do not have 4.5 feet of snow on my roof right now. I don't think I will tomorrow either. But that's if it's the same as the Stevens. Now if it starts raining on it, then who knows, right? Then the snow water that it could get much higher. But right now it's about 1/4 at least as Stevens. So we can assume it's maybe about that in Leavenworth. Maybe. So basically the water equivalent's about 1/4 of the snow depth. But that's not a general rule. It can change a lot. Anyway, I think I'm pretty safe right now. I don't think I need to go shovel my roof.
That
But-
is terrible.
It's a real pain and it's dangerous as heck, obviously.
You have to like strap it into like the side of your house.
Yeah, you should.
Weren't you like shoveling your roof and you almost got shot by that one guy?
Oh. No, I was not shoveling my roof. I was working on the roof. I was installing a stovepipe because I was putting in my wood stove. So I was up on the roof, and this guy was shooting, and he had to be shooting at me because he came pretty darn close. I could hear the bullet go whizzing by. But he was up target practicing up in the hills. I lived in Darrington.
What
Well-
year was this?
In Darrington, where I used to live, we lived out in the woods, on the edge of the national forest and stuff. And people would go up there because there's a road, a Forest Service road up in the hill, and people would go up there from Everett and everything. Oh, we're in the wilderness, and they'd shoot their guns and always doing stuff like that. Always like you'd think, oh, nice and peaceful on the weekend instead of like boom, 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 boom. People out practicing target shooting and stuff. And, oh, they're out in the wilderness. Like, yeah, my house is right here. Anyway, so I was up there going, some idiots out there target practice, whatever. And then I started hearing bullets. Like, oh my God, this isn't good. And I actually heard it hit a tree behind me, and I heard it whistling by. Like, oh, I get down the roof as quick as I could. We called the police. They ended up getting the guy. Oh, I didn't know. I was just shooting bullets.
How could they be so close to you?
Yeah.
It's really bad. Or
You know,
like trying to
I
kill
could
you.
see where he might have been. He was up on the hill, and trees were blocking the view of the house. He might not have known that because we were surrounded by trees. He might not have known there's a house there.
You should retain.
And he was just like shooting in that direction because he's an idiot.
You're not close.
Yeah, it's very, yeah. That's I barely
When
remember
did
that
this
story.
happen?
That's pretty good. This is when I lived in Darrington. So I moved here in '99, so maybe '97. People aren't that dumb anymore.
Well, no, we had
I don't think he was shooting at me. I think he didn't see me and was just shooting in that direction. Didn't realize there was a house there. Yeah. Anyway,
Probably.
so beware. Anyway, I don't think I need to. I got worried yesterday and I saw the neighbor, but that's an older house, and I don't think he really needed to anyway. But he was just being cautious because there is a big storm coming, and if it rains a lot now on top of snow, which it often does around here, then I need to start worrying. Right now, I don't think I need to worry. But anyway, so those are just some numbers to keep in your mind.
We'll shovel your roof if you give us extra credit.
Absolutely, yes. We get a whole team. It'll
Yeah.
take like 10 minutes.
Whole team, and
Yeah, we'll all
And
go
then
out there.
all of our.
at least one person will fall off, but then the chances that it's you will be smaller, right?
Yeah, you just put the money.
Now, if the snow is deep enough, you fall off, you just land in nice soft snow, right? Who cares?
Yeah, it's fine.
Yeah.
Like, I'll do it. I was.
Yeah, yeah, appreciate it. I might have to call you on that. All right, anyway, we have not a lot of time. So if you want to look at these graphs, by the way, I just Googled Stevens Pass SNOTEL. So it's called the SNOTEL graph. I'm not sure what TEL stands for, the S and O I get. But
Or is it like hotel, but snowtail?
yeah, I see like why Stevens Pass SNOTEL. If someone can figure that out, I don't know.
Or are
But
they telling you about the snow?
Oh, that's probably what it is.
But look at that. Look how high that got to.
What year was
72
that?
inches of water. Oh, okay, that was in March. It was the 97. It was the 96, 97
It's because Bill
winter.
Clinton was president. He knew the snow a lot.
Yeah, in March of 97, it reached 72 inches of water. 6 feet of water, so it's probably like 30 feet of snow or something.
Yeah.
Well, if you triple it, right now you quadruple it. Oh wait, no, if you quadruple 6 feet, it'd be 24 feet.
That's still ridiculous.
Maybe like 24 feet of snow.
It's still like.
Yeah, can you imagine at the pass? So where you shovel it, can you imagine like you'd have to throw it up? You need a pretty good snowblower to throw up. You can't even do that 24 feet in the air.
Like if it were to be powder, like could you like suffocate? Like,
Yeah,
easily.
you would fall into it. You can't get out.
Like in Minecraft.
Well, you can kind of compress it as you get out. It'd be like falling in a tree. That'd be bad. Crazy.
Covered snow. It's me every time.
All right. Anyway, good stuff. Okay, let's look
It
at
says bad.
calculus. Okay, this is number 4. You should have gotten infinity, which is pretty obvious. When x goes infinity, we have infinity times infinity. So this is actually a really easy one to do this limit. All you have to do is plug in infinity. There's actually no work to do. So if you plug in infinity here, you clearly get infinity times infinity squared. Okay, that one's easy. So A, you should have gotten infinity. B, you should have gotten negative infinity. And that's because, right, negative infinity squared is positive infinity, but x to the 1/3 keeps the negative. Cube roots keep the negative, so it's negative infinity. So B, you should have gotten negative infinity. Then C, there are 3 x-intercepts. Now to find the x-intercepts, you got to say y is 0. When is y 0? Y is 0 when x is 0 or when x is equal to plus or minus 8, right? Because x squared minus 64. When x is plus or minus 8 or x is 0, you get the you get y is 0. So those are the y is 0. Those are the x-intercepts. So 0, 8, and negative 8. So they wanted you to put negative 8 in the leftmost to the right. Okay, so that was easy, kind of. And then that divides 4 intervals. So now they want to know the sign indicate the sign of the function on either side of these by putting positive. So that's just, again, this just helps you with graphing, right? Is the function above the x-axis or below the x-axis when between those 4 places? Because we know it crosses the x-axis in 3 places. So when is it above, when is it below? So you just got to plug in numbers. It's a pain, just calculator work. Plug in easy numbers like 1, 0, whatever. Okay, so you should have gotten that it's negative is below the axis between negative infinity and what's s? Oh, they didn't want to put the number in, so they put the, oh, that's terrible. Okay, whatever. So that's what you do there. And then what is the formula for the formula? Formula for the derivative. So we had 7x squared minus, and they keep saying 8 squared because that's the number that can change. So you can put 64, obviously. So that's the derivative. The critical numbers, there are 3. So for f, where is this 0? And notice that x equals 0 is a critical number. Where it's undefined, just like the one we did beginning of class, is a critical number because x equals 0 is okay in the original formula. See, if we plug in x equals 0 into this formula, there's nothing wrong with that. We just get 0. 0 times negative 64. So 0 is in the domain of the function, but it's not in the domain of the derivative. It's undefined the derivative, so it is a critical number. So this is another case where you got to be careful of undefineds. So there are 3. Negative 8 over square root of 7, 0, and 8 over square root of 7. Okay, now, for critical numbers, it's interesting to know what the derivative is. So they say determine the function is increasing, which means is the derivative positive, or decreasing when the derivative is negative. So you basically break it up into 4 sections, and you plug in numbers. Again, it's a lot of work. And on the final, you're going to have to do this work. I mean, there will be one like this in the final, because there hasn't been one like it yet. So you make your number line, you put your numbers on it. Oh, it was a horrible derivative. What was the square root of 8 over 7, or I don't know what it was.
8 over the square root.
8 over square root of 7, and then 0, and then positive 8 over square root of 7. So you got to plug in a number here, plug in a number here, plug in a number here, plug in a number here into the derivative, and figure out if the derivative is positive or negative. Chances are good it alternates, but it doesn't have to. You could have 2 positives next to each other.
Well, it doesn't alternate for all of them because 0 isn't a max right.
Okay, right. So it's undefined here, so this is an asymptote. Now it could alternate, but it might not. So you got to be careful. So it could be, okay, they tell you what it is. So it's, what's I stand for?
Increasing.
Increasing, so that means positive. So positive, negative, negative, positive. So if you plug numbers in, you should get that the derivative is positive, negative, negative, positive, which is kind of interesting here, right? So basically it goes down, the function looks like this. It goes down to negative infinity there, because the slope is the slope is negative there. So that's a positive slope. So it looks like it goes down this way and goes up that way. Wait, that's positive slope. What's negative slope look like?
Isn't this about just where it is on the graph? Oh wait, no.
How was the other one?
That was the first.
Yeah. Okay, then there is a local minimum. So where is the slope 0? So the slope is 0, so it turns out that 8 over root 7 is the local minimum, and negative 8 over root 7 is the local maximum. Now, how are you supposed to know that? We know the slope is 0 there, but how do you know if it's a maximum or minimum? And the way you know is because it's positive here, so it's going up, and then it's going down. So it's got to be a maximum. We know the slope is 0 here, and if it's positive one side, negative on this side, it's got to be a maximum. Over here, we know it's negative positive, so it's going down and then going up, and we know it's 0 there, so it's got to be a minimum. So by the first derivative, we don't have to do the second derivative to figure that out. We can figure that out from the first derivative. So making that table is important. Drew a number line, figure out the derivative. It's a lot of, plugging in numbers. It's a pain, but it's not hard. It just takes time. All right, now they want you, what happens when x goes to 0? And it's an asymptote. You get negative infinity. That's, again, obvious, just because you're dividing by 0 there, so it should be negative infinity. There's a vertical tangent line, yes, because that's what negative infinity means, that's true. The formula for the, second derivative, it's not too horrible a formula. Okay, where's the inflection point? And they want to know the x and the y value, so that's where the second derivative is 0. Or it switches over from, switches over. Remember, it's not always, the inflection points are not necessarily where the second derivative is 0. It's also where the second derivative could be undefined. So is there a place where this is 0? Oh, there is. So we have, oh no, there isn't. So is this ever 0? So we have this 28x squared plus 128. Can that ever equal 0? The top can't be 0, can it? Because x squared is positive. So there is no place where the second derivative is 0, but there is a place where it's undefined at x equals 0. So that's why they say x equals 0. So at x equals 0 is an inflection point. Now, we don't even know that because really we have to show what is the second derivative on either side of x equals 0. It's got to switch from negative to positive, and I'm not sure it does yet. All I know is the second derivative is undefined there. So being undefined doesn't mean it's an inflection point either. So we got to figure out what it is on either side of 0. Because we know that, so 0 could be an inflection point. So what is it maybe at negative 1? What's the second derivative at negative 1? What's the second derivative at 1? And if it switches, we know it's an inflection point. It's where the second derivative switches from positive to negative, or in other words, concave up to concave down. So that's really what you have to do for this. On a test, you're guessing you have to show, you have to prove it, right? So if you do that, let's plug in 1. That's easy. It's positive number on the top, divided by 1. That's a positive number. So it's positive on this side at 1. Second derivative is positive. Now let's plug in negative 1. This is positive on the top still. Same difference. But negative 1 to the 5th and 3rd is negative. So it's negative. So yes, it does switch from negative to positive there. So it is an inflection point. The second derivative switches from negative to positive. Okay, you got to do that work to prove it. You can't just assume. Okay, a lot of you guys didn't get all the way this far, but these are like the easier ones, I think. True, false is concave up at x equals 1. That's true because the second derivative is positive at x equals 1. We just showed that. Second derivative is positive x equals 1, so it's concave up.
Wait.
And then we just had to choose a picture. It looks like A. It looks like that. So the answer is A. So at 0, the slope is undefined. It's vertical. There's a minimum here at 1. There's a maximum at -1. And it goes to infinity, it goes to negative infinity. So you should be able to draw this picture. Now, a lot of times you don't care how high this is, just what's the overall shape. Sometimes you'll actually want to find that point and that point. Those are the only points you need to find, right? 0, 0 is easy. If you find those 2 points, you can draw a really good picture. And again, the only inflection point is right here. Here it's concave up, here it's concave down. It switches over right there. There's no other inflection points. Okay, I really don't think this one was that hard. You just got to force yourself to think. A lot of you did a good job finishing all the way through. Some people got lost in some of the parts, which is understandable. That's why we do examples. But eventually, you need to get this stuff. Like, okay, I get it now. If you didn't get all the way through, try it again on your own. We have one more to do here. So the last one on this assignment, we're done with web assignment 23. I also gave you a practice quiz. The quiz won't be this week. I want to go over that. Now, there's only 2 problems in the practice quiz, but as you know, 2 of these problems is a lot of problems, right? Each one can take a long time. I gave you a sine one where there's an interval because sines go on forever. There's a million peaks and troughs. We can't find them all. So, okay, let's only look between here and here. How many peaks and troughs, how many max and mins are there between here and here? And then I gave you a fractional one where you have some weird stuff, you have some undefines, all that kind of interesting stuff going on too. So on the quiz, it'll be something like that. So, and it's long, so you need to be able to work through it. Okay, so let's, again, the practice quizzes I don't grade, but if you want to do well on the quiz, you better do it. We'll go over that eventually, but for tomorrow then, finish up WebAssign 23. Finish number 5. Let's try to get all the way through. I don't even know what it is, but it's probably hard. What does it look like? What's number 5 look like? We'll see it right here. Okay, this is, oh my gosh, it's got an absolute value in it. Okay, just give up now.
Oh no.
Oh, no.
I am done.
Okay, all that means is we can put a negative x. Negative x is okay. We don't have an I, right? Okay, everybody remember when you get absolute values, how do you deal with absolute values? You treat them like normal, but you break it up into 2 problems. Where is x negative? You make x positive. Okay, so here, if x is positive, we don't need the absolute value. So what you do is you break this up into 2 problems. You say for x greater than or equal to 0, we got to include the 0 somewhere. Then, what is our formula? Our formula is square root of x plus x over 10. We don't need the absolute value because x is always positive. For x less than 0, then we make it positive. So then our formula is square root of negative x plus x over 10. Because if x is less than 0, negative times negative makes it positive. So basically, we replace the absolute value with the negative there. And we're okay, because x is always negative, so we know it's a positive. So basically, we have 2 problems to do. When x is greater than or equal to 0, this is our formula. When x is less than 0, this is our formula. And so you just got to look at each side now. So again, the way you deal with absolute values is you get rid of them, which means you got to have 2 different domains for x, which is like kind of twice as much work. But the derivative is the same. Actually, it's not the same. What is the derivative of this? Yeah, it's 1/2 negative x to the negative 1/2 times the derivative of what's inside, which is negative 1. Here, the derivative of what's inside is 1. We don't have to do the chain rule. But here, we got to do the chain rule. That's kind of messed up. Now, this one stays the same. Wait, does it? I'm sorry. Does it stay the same? Oh yeah, it does, because there's no absolute value there. No, I'm sorry, it does, because we just give it absolute value. There's no absolute value there, so that stays the same. So that's just 1/10. That's easy. Alright, a little bit crazy. But hey, if it was easy, anyone could do it, right? Alright, so finish this for tomorrow. Don't worry about the practice quiz yet, or if you want to start worrying about it. My guess is, what's today, Wednesday? My guess is the quiz will be like Monday or something. The quiz can be open notes. I mean, if you want to use notes, I don't care. Because you just have to be graph stuff, right? So if you want to use notes in the regular quiz, use your practice quiz, whatever, to help you see how you do it. But you just got to be able to follow the steps and do stuff, right? Where's the second derivative equal to 0? Where's the first derivative equal to 0? Undefined. All that good stuff. We still have 6 minutes. Yeah. Yeah. But each one is like got 15 parts, so 5 questions a lot, right? But yes, there are only 5. This is the last one. Yes. That's where x goes to infinity. So you have 2 limits. The limit is x goes to positive infinity, the limit is x goes to negative infinity. So yeah, that's about dealing with limits. And many times it's easy. It's obvious. It's only sometimes where it's hard. Usually you just plug in the limit and see what happens.
I looked online and
Yeah, now one's gonna be easy, right? Because we use the old rule.
Jasper was
Square the bottom, it
eating
wins.
lunch without masks.
Or you divide by the, yeah, so it's
It's just a positive that night.
so and negative. Then the only question is, oh yeah, negative infinity doesn't matter if it's 0 or 0.
Yeah, but how can I consider it? But then it said you were supposed to wait. I don't have a problem with that.
But it's still not.
Well, you test positive. Like when I had it, told me not to.
Recommending class.
I thought you weren't supposed to do that.
Haken, you're going on Wednesday, right?
Yeah.
As far as I know, it's still happening. Quentin, you going Wednesday? Knowledgeable? We think so, okay. Check that. Olivia?
Yes.
Tilly?
Yes.
You guys are going to be gone.
Yeah.
Sorry, I
We're
couldn't
not
go
doing
Wednesday.
the competitions this year.
Okay. So you aren't going. Anybody else? And Chase? Wednesday. Knowledgeable. Next
I
Wednesday.
would probably be here, yes.
Probably. Okay, check that. Chase.
Honestly.
Anybody else in here? I guess that's it from here.
Oh, what is wrong? What is, if he gets tested again? It's positive.
I need to stop this video. You guys got some extra here.